So I'm going to Desmos, that online graphing calculator, and I typed in y equals a sine bx. We should know right now if the variable that a, that's going to be a number, but it's a right now because we can change the number. Oh, right now I have the wrong number too. If the a value is it outside of the sign, it's in front, it's being multiplied, what does that tell us about transformation?
Vertical.
You can't see? I can't see him. I'm sorry. Maybe I can this way. You see it now?
I liked it the other way better. This is too extra.
I don't understand what you're talking about.
Oh, is it a vertical stretch?
It is a vertical stretch or a vertical shrink. The B value, which I've also made a slider so we can change it in just a moment. The B value is multiplied by the X. So that is is not a vertical. That is a horizontal stretch or shrink. Okay, now I have to zoom it back out so we can actually see the graph. Okay, and then if I take this slider and I make it bigger, do you see how the graph is now being stretched vertically? What's happening to the x-intercepts? They're staying the same.
What happens if you make it all the way negative?
Good question. What should happen?
A straight line. Oh.
If I do negative, what's going to happen?
Oh.
It's going to reflect in the x-axis.
That makes
What happened? How would it make a straight line? What would I have to make a value? 0, right? Because if it's 0, then there isn't a sign anymore. Where is 0 on this line?
I see.
All right, so I'll put that back at 1. And then for the B value, what happens if I increase the B value?
It's going to shrink
Shrink which direction?
horizontally.
So this is my sign, and I stretch horizontally. Look what happens. What's happening to the one complete cycle when I shrink?
Getting small.
Yeah, the cycle's shrinking also.
How small can you get it? Like all the way?
Well, I can go past 10, but this only allows me to go to 10. So, and then if I go between 0 and 1, it's then a stretch. So stretch horizontally. If I go to 0, then there isn't anything. If I go negative, it is now a reflection in the y-axis, but it's going to look the same as the reflection. Well, I guess it doesn't look exactly the same, but it looks similar.
What if you gave us one of the one where it was at a 10 on like a test, we had to graph that entire thing? That'd be terrible.
I wouldn't, because I'd have to grade it. I'll always give you like decent answers so I can actually grade them too. And the next thing I want to show you is really cool. It is this is a sound. It says human audio spectrum. So you know that if the sounds are really, really, really low, we can't hear them. Or they're really, really, really high, we can't hear them. There's only like certain sounds that we can hear. And frequency has to do with the period. It has to do with the horizontal stretch or shrink. So you'll see the picture changing, and then you'll hear the sound. And I would like it to be quiet. You shouldn't be listening to music while I teach anyway, but definitely not, because I want you to listen to hear when you can actually hear the sound. So when you can hear the sound, you're not going to be able to hear it first. When you can hear the sound, you can kind of like, but not too loud because we want other people to be able to hear it.
I'm sorry.
Okay. What? No. It's going to be a tone, and you'll see the tone will change with the frequency changing. All right, ready? 2:24. Here we go. 2 minutes 24 seconds. You don't hear it yet. That's it. That's the sound.
I thought it was an
Yeah, the sound before was something else. That's why I was like, you can't hear it. You can't hear it. I promise. All right, so it's gonna keep getting. You're gonna be able to hear it for a while. It's gonna keep getting higher and higher, and they're gonna keep getting closer and closer together. And eventually, we're not gonna hear it again. So we'll do the same thing again. I'll raise my hand when I can't hear it, but I'm kind of deaf, so you might be able to hear it longer than me.
Like babies, they can hear like really high.
Can they?
This is fantastic. I love this.
But like
This takes me out of
All right, we're not gonna be able to hear if you're on top.
like aliens. That's so sweet. I hear that shrieking noise all the time in this ear.
Sometimes, sometimes like my ear will do that too. All right, so that was I just wanted to show you that because there is use for these curves in real life, and there's other usages other than sound, but I thought that was interesting. Okay, so let's do just a couple more examples. We'll do this next one here together, review what we were doing before lunch. We are graphing and finding the information. I lost my pencil. So we're going to look at this equation. You see that it's sine. So when we do sine, what do we begin with at 0? 0 is 0. Sine starts at 0, then we go 1, 0, -1, 0. And it follows that up-down pattern to 1, to 0, to -1, 0.
How do you know it goes to 1 and not -1?
Well, I can picture the unit circle, and sine is y, so 0, 1, 0, -1, 0. So you can, if you're not sure, you think about the unit circle and going that way around. The transformations, what's the negative do? Okay, so we say reflection in the x-axis, and then the +4 is translate up 4 units. And I expect after the third chapter that we're doing transformations in, plus after Algebra 2, that you are using the correct vocabulary at this point. So reflection at x-axis is actually a vertical change. It's outside of the function. It's not in parentheses. So we're going to multiply the what by -1? The y values by -1. And then the translate up 4 is also vertical. So we will add 4. And remember, we always multiply before we add order of operations. And how do I know by looking at the equation that the +4 is a vertical and not a horizontal? Does anybody know? How do you know that? Well, we said it was up, but before we said it was up, we
the X and 4 is not together.
it will be in parentheses if it's a horizontal shift. Okay, it will be in parentheses, and it's not. Okay, so we're going to graph the outermost x and y, 0, 4, pi over 2, 3, pi 4, then 5, then 4. You don't have to, but I'm going to color in my original points so you can see what they were before I continue the pattern with just using a pattern.
How did you do that so quickly?
I had some practice.
I was literally just finishing my third dot and you're already done.
Had some practice. Then we need to answer some questions. So was there a horizontal stretch or shrink on this one? There was not, so the period is going to remain at 2 pi. The amplitude has to do with the vertical stretch or shrink. The amplitude is also, another way to think about it is how far above or below the midline does this graph go? How far up? 1. Now there was a negative one that we multiplied by, but the amplitude is not a reflection. So we don't put a negative, we just put 1. And then the sinusoidal axis is also the midline. It's the equation of that midline. So we are going to have y equals, what is the y at that line? 4. The domain is all the way to the left, all the way to the right, so negative infinity to positive infinity with parentheses because it can't equal infinity. And the range is how far down to how far up. So the lowest point is 3. It can equal 3. Highest point is 5, and it can equal 5. So we need brackets. We're going to skip to number 5.
Wait, hold on.
I'm holding on.
What domain is X, right?
Yeah. And then anything that I skip or I go quickly through, it will be posted on Canvas. I will post all the notes on Canvas. I'll make sure it's all complete before I upload a file. Just in case I go too fast for you. What? They're helpful. Well, I don't know if they're helpful. I think they're helpful. They're better than what I had when I was in high school or college. Okay. The next one, number 5. We're going to do number 5, and we look at this and we see that it is sine. So what does sine start at? 0, 1, 0, negative 1, 0. And then we're going to write our transformations because that will help us fill out our table. So transformations, we've got a 3 in front. What does that 3 mean? Vertical stretch, factor of 3. And then we will have a 1/2 after the word sine, but before the x. So it's going to be horizontal. And horizontal is always opposite. So is this a stretch or a shrink if it's a half? It's going to be a stretch. Yeah, we're on 5. And we write by a factor of 2. It's always opposite. And then the plus 1, is that going to be left 1 or is that going to be up 1? How do you know it's up 1? No parentheses. So translate up 1 unit. In my table, if it is a y, like vertical stretch, we're going to multiply by 3 and then we're going to plus 1 for the y values. But the x's, since it's a half in the print or in the equation, instead of multiplying by half, we would multiply by what? 2. So we're going to change our x values this time. So when I go to multiply my x's, 2 times 0 is 0, but 2 times pi over 2 is pi. 2 times pi is 2 pi. 2 times 3 pi over 2 is 3 pi. And 2 times 2 pi is 4 pi. And then the y's I'm going to multiply by 3 quickly and add 1. So there's a horizontal stretch. Are we going to have more bumps or less bumps? Stretch it horizontally, we're going to have less bumps. So you can kind of think about these words and what your picture is going to look like. I'm going to go ahead and graph the outermost x's and the outermost y's. 0, 1, pi 4, 2 pi 1, 3 pi negative 2. Oh, I put in the wrong spot again. I'm not paying close enough attention. And then 4 pi, what am I going to do? Not graph it? Okay. So I'm just going to have to follow the pattern after this. I just have to figure out what the rest of the pattern looks like. And I know that this graph should be this nice rolling wave looking thing. So I think I'm going to go down next when I go the other direction. And then midline, and then up. So it's certainly stretched horizontally, it's stretched vertically, and then it is, the middle line is bumped up one. So for figuring out our period, there's certainly different ways of doing it. I'm not going to just give you a formula, which is what you may have been told in the past. I'm not going to just give you a formula. I want you to like understand what the period is. The period is one full cycle, the horizontal distance.
Yeah, that's what I'm confused. How'd you figure it out that was it? Because that's the chart we made? And how'd you figure out that was
Yes,
it?
that's the chart.
Well, what if you gave us additional number on the chart?
I'm not going to.
It's always going to be 5.
Yeah. So you're always going to do this chart. You can always put more on, but this will always be one period. Okay?
Okay.
So when I give it to you, it's always the one cycle. So horizontally, how far do we travel if we start at 0 and go to 4 pi? Horizontally, from 0 to 4 pi, how long is that? It's 4 pi long. So my period is 4 pi. I'll also tell you, since the period is affected by the x stretch or shrink, the period's normally 2 pi. And whatever we do to all the x's, you do that to 2 pi. So 2 pi, we multiplied the x's by 2. That's how we got 4 pi. So it's affected by the stretch or shrink. That's how we get 4 pi. The amplitude is how far above or below the midline. It's the vertical stretch or shrink. What's the amplitude? 3. The sinusoidal axis is the midline, so y equals 1. The domain left to right, negative infinity, positive infinity. What's going to change the domain? Brian? Oh, yeah, but without me changing the equation, if it's still y equals sine x with some transformations, will I have a different period? No, because it goes on forever. So for now, it's easy. There's not a different period. So yes, if I were going to change stuff around, it would, but just with the transformations we learned so far, the domain's always going to be the same. So how about the range? What's the range for this one? Lowest point? -2 to the highest point, 4. And you can also get that from your chart. It should be the lowest point and the highest point in the chart. All right, one more. Do number 6. So cosine starts where? 0, 1, 0, -1, 0, 1.
So you just go the opposite. If it starts at 0, you go up. And it starts at 1, you go down. Pretty much.
I guess, but when I think about the unit circle, cosine's the x. So I start at 1, and then I go to 0, and then I go to -1. The x value, right on the unit circle. Mm-hmm. Okay, transformations. The negative is what? Reflect in the x-axis. The 2 is a horizontal shrink. What factor? Factor of a half. And then the -2 is a translate down 2. So in our chart, for the A, I'm going to multiply all of those by -1 because that's vertical. The D would be translate down to, so -2. And then over in the B, that is my horizontal shrink, so I multiply by 1/2. So you will have this on a non-calculator section. You might have to multiply fractions. Yes?
So if it's under 1, it's with x and variable, it's a shrink goes horizontal.
I'm sorry. Start over. So, okay, so if it's between 0 and 1,
Right.
and it's with the x,
Yes.
then it is a, well, wait. Are you talking about in the equation, or you're talking about in the equation? Right here.
Vertical
Vertical, like, makes sense.
vertical shrink is like between 0.
Mm-hmm. And it's like fractional, right?
Horizontal shrink is
The opposite.
the opposite.
It's the opposite. So if it's like bigger than 1, then it's a shrink.
Oh, factor of 1/2. Okay, it's 2.
Right. And when I talk about it being opposite, I'm talking about coming from the equation, not from over here. This I've already made it opposite. Okay? Okay, so I'm going to go ahead and fill this out. When I multiply by 1/2, well, the first one's easy, 0. I'm going to take like pi over 2 and times that by 1/2. So you multiply fractions straight across. Pi over 4. And then pi times 1/2, that's just half pi. Pi over 2. Then 3 pi over 2, and you multiply that by 1/2. You multiply straight across, you get 3 pi on top and 4 on the bottom. And then 2 pi, half of that is just pi. So those will be my x values, and then my y is just multiply and add, or multiply and subtract. No. Come on. Okay, go to graph this, and 0, -3 is easy to graph, but then pi over 4 isn't given to me on my graph. Oh, but it is exactly in the middle of 0 and pi over 2. It's half of pi over 2, so right in the middle. There we go. And then pi over 2 is at -1. And then 3 pi over 4 is also not on our graph, but we can find that. It's in between pi over 2 and pi. It's like 3/4 of a pi. 75 cents.
Is to do all of them?
Mm-hmm. But once you get going, it's almost hard to stop. I said almost.
On homework, would you take off ones if we didn't do the rest of it?
Yeah.
Okay.
No, I took off points on quizzes and tests where people didn't do it all. If this is being a little tedious, but I want to make sure that you are showing the information correctly. At the end, if you made your arrow do this one here, I would take off. Because the arrow, it doesn't go down from there. It like curves back around, so you'll see my arrow will curve back around.
Great.
But after practice, it just comes natural. You know where it goes next. Now we got to fill out this information quickly. What is our period?
Pi.
It's 1 pi. And to think about that, we normally have 2 pi for our period. But since we multiplied all of our x's by half, we would half that also, and you get 1 pi. Or you could look at the graph and say from here to here, 1 period is pi long. The amplitude from the midline up or from the midline down, how far is that? Just 1. And that's the vertical stretch or shrink, and there wasn't one, so 1. Sinusoidal axis is the midline, y equals -2. Domain from -infinity to +infinity, and then range from lowest point, -3, to highest point, -1.
Will you ever have a wavy line that goes like this?
You could.
Like, because.
We won't.
Because it says y equals -2, could it ever be x equals something?
Yes, and you know what that's called?
No.